Hello and welcome to Cosmological Arguments. I'm your host, John Bannan. In this video, I'm going to explain the Schrodinger's cat and what it means exactly and how it is that you can get out of it as a theist. Schrodinger's cat is a thought experiment created by Erwin Schrodinger, who's this famous physicist. And it has to do with the nature of reality at the quantum mechanical level. What this thought experiment says is, imagine you have a cat and you have a box. It's an opaque box. So you take the cat and you put it in the box. So there's our cat, he's inside the box. And in the box, place a glass vial of poisonous gas. And create a mechanism where the glass vial is broken and the gas is released, depending on whether a Geiger counter registers the decay, the radioactive decay of a particular atom. So you create this mechanism. So if this particular radioactive atom decays, the Geiger counter registers the decay, the hammer comes down, breaks the vial of gas, the gas is released, and it kills the cat. So now, this is a soundproof box, you can't see in it. So close the lid. So now you're an observer out here. And you've closed the lid and you can't hear anything from inside. And what this says is that after a while, because of the acausality of the decay of a radioactive atom, a particular atom, the quantum states of whether the atom decays or whether the atom doesn't decay, these two possibilities are superimposed upon one another. And because of that, it's indeterminate or uncertain as to whether this mechanism is going to break the glass vial and kill the cat. You just don't know. So, in this thought experiment, the answer is that, well, is the cat alive or dead? The answer is that the cat is simultaneously alive and dead because of the superimposed quantum states, making it just indeterminate as to whether this glass vial and its poisonous gas has been released or not and killed the cat. So, Schrodinger's cat says that, well, is the cat alive or dead? Well, it's both alive and dead. It's in a quantum indeterminate state of superimposed quantum possibilities, and you can't say whether it's alive or dead. So it's both simultaneously. Now, you may hear this argument given by non-believers or atheists for the proposition that um, whether this cat lives or dies has no cause. There's no cause to it. It's a probability of whether it lives or dies based on the probability of whether a particular atom, radioactive atom, decays or not. But you can't know. So you don't know whether the cat's alive or dead. It's in an indeterminate state. And the determination of whether it's alive or not is only made once this lid is reopened and this person looks in the box to see whether the cat is still alive or is dead. So when the person observes the superimposed quantum state, that's when the quantum state is resolved from those two possibilities of the cat being alive or the cat being dead, and the determination in reality is made whether the cat is in fact alive or is in fact dead. So the argument is that realization of physical reality from superimposed quantum states is not caused. It's not a caused thing. Whether the atom decays or not, it's called acausal physics. There's no cause to it occurring. There's a probability of it occurring, but there is no actual cause. So, the Schrodinger's cat is basically an example of acausal physics. And it's claiming that there's this simultaneous dead and alive state of this cat, and there's no cause for whether reality decides for it to be a live cat or a dead cat. So the argument goes that, well, because it's an uncaused phenomenon, that if reality can be caused by something that doesn't have a cause, then ultimately reality is uncaused. In other words, the cause comes from nothing, nothing itself. Acausal physics is an argument of causation from nothing. And of course, if nothing can cause things, then you don't need a God to cause anything. So this is ultimately an argument against the existence of God. So is this true? Is this Schrodinger's cat thought experiment true? Is it really an uncaused determination as to whether the cat lives or dies? Well, the answer is no, it's not. I'll explain to you why. So, is acausal physics truly uncaused? The answer is no. It clearly does have a cause. You can't pinpoint the cause. The cause may be unknown or undecipherable, or what we might call random, but it clearly has a cause. And the cause is the Big Bang itself. The beginning of the universe created the quantum field. And all quantum mechanical phenomenon, like Schrodinger's cat, occurs in a caused quantum field. It's caused by the Big Bang. So the Big Bang is the ultimate cause of all acausal physics, including Schrodinger's cat. So you can't say that acausal physics is not caused. It is by the Big Bang. Big Bang creates the quantum field, which most of us consider space. Outer space is the quantum field. And that's what's responsible for these quantum mechanical phenomenon, these acausal phenomenon. We may not be able to pinpoint exactly how it's done, but it does flow from or is caused by the Big Bang. Uh, there's another argument for why it's caused, and that is a phenomenon called quantum entanglement. Now, quantum entanglement is a strange quantum mechanical phenomenon that is real. And what it involves is the entanglement of two particles, such as the particle of light or the photon. So these two particles of light, for instance, they get entangled, which you can put them in an entangled state, which means they get the same exact quantum reality. They're in the same quantum state. That's what it means to be entangled. So you get these two photons and you entangle them, and then you separate them. So this one goes that way, and that one goes that way. And they can travel as far apart as you want, halfway across the universe if you want, and in billions and billions of years of time. So you have these two entangled photons separating from one another, going the distance of half the universe, maybe 5 billion years later. And you've got these two entangled photons. And quantum entanglement says that if you measure the one photon, let's say the spin of that photon, you will automatically know what the spin of the other photon is before you measure it. And when you measure it, sure enough, it's exactly correlated with the other entangled photon spin. Now, this is extraordinarily odd because ordinarily, these photons, they're acting like ordinary photons, just ordinary photons. You can't tell the difference between an entangled photon and just an ordinary photon hanging out. There's no way to tell the difference between these two. It's the same exact particle. And they have a quantum mechanical nature about them such that it's a probability as to what the spin will be when you measure it. So that's not certain either. So how come an entangled photon, which looks no different than a regular photon, and let's say the odds of a particular spin are 50-50, how come that when you measure it, if it's entangled with another one, the correlation is 100% with the other photon that you previously measured? It defies the indeterminate quantum mechanical state of the photon. How does the photon know, the entangled photon know? How does this one know what spin was measured on the other one, even a half a universe apart and 5 billion years apart? How does it know to show this particular spin? Because it should be basically 50-50, just like a regular photon, but it's not. It's a 100% certainty that it will be the same spin as this one. So this is quite a conundrum, how it is that this happens. Quantum entanglement is also the basis of quantum computing, this whole new area that computer engineers are researching because of this phenomenon, which is real. It allows you to compute things much, much faster. So this is a real thing. People are working on it. So what's the explanation? Why is it? How is it that the entangled photon knows what the other entangled photon is doing? You could say, well, maybe they're communicating with one another somehow. But you could separate these entangled photons half a universe apart, and you measure one, and you will know the measurement of the other one, and you can do those measurements before there's any time in order for one to communicate to the other one what its spin was at the speed of light, because you can only communicate as fast as the speed of light. And if you're half a universe across, it'll take you, 150 billion years to get the information, well, maybe not that much, but maybe 50 billion years to get the information to the other photons. So if they're measured practically one after the other, there's no way it could be subluminal or communication faster than the speed of light that's letting this other photon know what spin it should be. So what's the answer? How is it possible that that could occur? And the answer is something called superdeterminism. Now, superdeterminism is the idea that at the moment of the beginning of the universe, the Big Bang itself, um, everything was predetermined. Everything that will ever happen in the universe, from the past, present, future, is fated to occur. It's all predetermined based on correlations established at the Big Bang itself. This is superdeterminism. So, what this means is that when the universe was created and the Big Bang first appeared, it was already determined what the spin of each of these entangled photons was going to be. So it's not that this photon is communicating with the other photon faster than the speed of light to set its spin up. It's that it was always fated and predetermined to be that particular spin. Because it was established by superdeterminism at the beginning of time, the beginning of the Big Bang. Now, what does this mean, superdeterminism? Well, what it means is there's no such thing as anything in physical reality that is strictly uncaused. There's nothing that Schrodinger's cat, in other words, it's not uncaused. The decision as to whether the radioactive element is going to decay or not has already been made under superdeterminism, and it was made at the beginning of the universe. It's just that the observer, the person waiting or who's going to look in the box, they don't know what has been predetermined. They don't know whether the cat is alive or dead. But the universe knows, and it's been predetermined from the beginning of time whether that cat would be alive or dead. So it's not a case where the cat is simultaneously alive and dead. The cat is definitely alive or definitely dead, and the universe, through superdeterminism, knows the answer and has always known the answer from the beginning of time. It's just that the observer doesn't know the answer. So that's your solution to Schrodinger's cat. It's superdeterminism, as evidenced by quantum entanglement. The truth is there are no uncaused physical phenomenon. They're all ultimately superdetermined by the Big Bang. Now, superdeterminism in itself is problematic for free will, because if everything is predetermined in advance at the beginning of the universe and you can't change anything and everything is set in stone, then can you really have free will? And it would seem the answer would be no. Clearly, you couldn't, because if even your decisions are determined, superdetermined in the future, and you can't change them, then how could you have free will? You could have an illusion of free will because you don't know what the future is going to hold, although the universe does, but you don't know. Just like the observer of the cat in Schrodinger's cat thought experiment. So you could have an illusion of free will, but do you really have free will? It doesn't look like you do under superdeterminism. But I would say this one thing. God can allow you to borrow his free will. God has the ability to create new reality or change the laws of physics or change what has been superdetermined under the laws of physics at the beginning of the universe. And we call those miracles. So God has the ability to change superdeterminism. So if God is in your brain through a miracle, directing your thoughts and consciousness, through his direct intervention in physical reality through a miracle, then you could avoid superdeterminism. Because God doesn't have causal chains, because he's divinely simple, he's not made of parts. God's direct intervention or miracle in your mind doesn't have a cause as God per se, because God doesn't have causal chains. So in a sense, you could say it is your will. You're borrowing your free will from God because God doesn't have causal chains. So it's just as easy to say it's your decisions than it is God's decisions. So in that sense, you could have free will through a miracle, a constant miracle in your thoughts and consciousness. But that's only if God exists, see? So if God exists, and theists believe he does, then you can have free will even under superdeterminism. So in summary, Schrodinger's cat does not prove God doesn't exist. All things are ultimately caused in the Big Bang. Superdeterminism and quantum entanglement proves that. And if you want free will, then you better believe in God, because only God can give it to you through a miracle in your mind. All right, well, hope you learned something. Take care.